Today we're gonna start with your chemistry 11 part 2, that has been in the class 5th. We had done in class 4 in the last session. Today we're gonna start with this, and that is we have completed your unit 1, unit 2, unit 3, unit 4, unit 5 and unit 6 with the unit 7. And this is your unit 8, which has been the redox reaction, where we had done all the reaction, all the 4 reaction with the dispersion, displacement and all these. Today we're gonna start with discussing about, which is we'll start the question. But before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe so that many and many. So here we're gonna start with, but before starting with this, it's a huge request to all the viewers to please go ahead and like, share and subscribe our channel. Here we go. Suggest a scheme of the classification of the following redox reaction. So with the same we go for it. That is your 6th question. So suggest a scheme of the classification of the following redox reaction. We have a first equation here that has been into gases form plus O2 gases form. It will give 2NO in the form of gases. So here in this reaction, the compound nitric oxide is formed by the combination of elemental substance, which is nitrogen and oxygen. Therefore, this is an example of the combination redox reaction. So we go for it. For this, the compound nitric oxide of nitric oxide is formed by the combination of the elemental substance nitrogen and oxygen. Therefore, this is an example of this is an example of the combination of redox reaction, and the reaction that B involves the breaking down of lead lead nitrate into three components. Therefore, so in this reaction, hydrogen of water has so with this involves this portion we talk for the paradox of fractional oxidation number. In the same way, sometimes we come across with certain compounds in which the oxidation number of a particular element in the compound in the fraction within fraction examples are. So for the same it will be C3O2, where oxidation number of carbon where oxidation number of sulfur is 2.5. Now on the same way talk about it, which is we know that the idea of the fractional oxidation number is unconvincing to us because the electrons are never shared, transferred in the fraction. Actually, this fractional oxidation state is the average oxidation state of an element that is under examination, and as the structure that is your parameters reveals that the element for whom fractional oxidation state is realized and is present in different oxidation state. Oxidation, that the structure of the species we have C3O2, Br3O8 and S4O62 minus, that reveals the following bonding situation. So we discuss all the structures here. So first we discuss structure of Br3O8, which is tribromo octaoxide. So we go for tribromo octaoxide. that is Br minus Br, that is being the bond. Double bond O, this is plus 6, and this is double bond O is plus 1, plus 6, double bond O, and double bond O with double bond O here. This is the structures of BrO8, where Br3O8, where Br is 3 and O, as you can count, it is in 8 here. And on the same way, we'll go for another structure, and that has been the another one, that is structures of C3O2. That is structure of O, that is C3O2, that is known as carbon suboxide. And for the same we go here, we go O double bond C, double bond C, strict double bond C, double bond O. This is plus 2, 0, and this is plus 2. Now we talk for another one, which is in another structure. Structure of S4O6. Which is tetrathionate ion. That we have here, and for the same we go for it. So for the same here we go S, that is double bonded with O, plus 5, double bond with O, single bond with S, which is 0, abstract. Then again single bond O, abstract, and S, double bond O, plus 5. So there will be the structure, and as you can see that the element that marked with the abstract is in each species is exhibiting the different oxidation state, that is oxidation number, from the rest of the atom of the same element in each of the species. This reveals that in C3O2, 2 carbons atoms are present in plus 2 oxidation state each, where the third one is present in the zeros oxidation state, and the average is 4/3. However, that the realistic picture is plus 2 for the two terminal carbons and 0 for the middle carbon. Likewise in Br3O4, and each picture, that is of the two terminals bromine iron atom are present in plus 6 oxidation state, and in the middle bromide is present in plus 4 oxidation state. Once again, the average that is different from that is different here from reality, that is 16 by 3 in the same fashion. In the species S4O62 minus, each of the two extreme sulfur exhibits oxidation state of plus 5, and the two methyl sulfurs that as 0. The average of 4 oxidation number of sulfur is S4O62 minus is 2.5, whereas the reality being plus 5.00, and that is plus 5 oxidation number respectively for each sulfur. Here on the same phase, we may thus in general conclude that the idea of fractional oxidation state that should be taken here with care, and reality revealed by structures only, and further whenever we come across with fractional oxidation state of any particular element in any species, we must understand that this is an average oxidation number only. In reality that revealed by the structures only. The element in that particular species is present in more than one whole and oxidation state, Fe3O4, Mn3O4 and Pb3O4, and there are some other examples of the compound which are mixed oxide, where we come across whose fractional oxidation state in the metal atom, however the oxidation state may be in fraction as at O2 plus and O2 minus, wherein the plus 1 by 2 and minus 1 by 2 respectively. Now we deal with the question that has been the other question we talk here, and that can be split into the two reactions that we have to. Why do the following reaction proceed differently? Pb3O4 plus Cl2 plus Cl2 plus 4H2O, and Pb3 plus 4HNO3 3,2 plus PbO3. So Pb3O4 is exactly an stoichiometric mixture of 2 moles of PbO and 1 mole of PbO2. In PbO2, lead is present in plus 4 oxidation state, whereas the stable oxidation state of the lead in PbO is plus 2. PbO2 thus can act as an oxidizing agent, and therefore that can oxidize Cl ions of HCl into chlorine. We may also keep the mind that PbO is a basic oxide, therefore the reaction we have will be in the form of Pb3O4 plus 8HCl 3Pb Cl2 plus Cl2 plus 4H2O. That can be split into two reactions, namely 2PbO plus 4HCl. This is acid-base reaction. And this is plus 4. This is minus 1. PbCl2, which is plus 2. is the redox reaction. Since HNO3 itself is an oxidizing agent, therefore it is unlikely that the reaction may occur between PbO2 and HNO3. However, the acid-base reaction occurs between PbO and HNO3 as it will be 2PbO for HNO3, 2PbNO3 plus 2H2O. It is passive nature of PbO2 against HNO3, and that makes the reaction different from one of the following with HCl. Now here we're gonna end up with this, and we'll discuss the rest in the next coming class, which is of course the 6th class of the session. But before ending it up, we had dealing with the chemistry for class 11th. We had part 1 we had completed, and part 2 we are dealing with the unit 8, that is been the redox reaction. Other than that, part 1 physics for class 11 we had started. We had completed their physical word and units and measurement. We are dealing with your diagram, even though we are dealing with the computer based numerical and statistical technique. And here in the chemistry part 1 we had done some basic concepts of chemistry. Unit 1, unit 2 is the structures of atom, unit 3 is your classification of elements and periodicity or in properties, unit 4 is chemical bonding in a molecule and molecular structure, unit 5 is states of matter, unit 6 thermodynamics, unit 7 is equilibrium. Unit 8 we had started with, which is redox reaction. That is being the classification classical ideas of redox reaction, oxidation and reduction reaction. Redox reaction in terms of electron transfer reaction, oxidation number, redox reaction and electrode processes that we have to talk about it. Unit 9 is your hydrogen, unit 10 is your the S block element, the unit 11 is your P block element, unit 12 is your organic chemistry, some basic principles and technique, and your unit 13 is hydrocarbon, and unit 14 is environmental chemistry. So here we're going to end up with this, and we are dealing with the quantitative aptitude as well. We had started with the arithmetical ability. So here we're going to end up with thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on a comment box. Please like, share and subscribe our channel so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. Thank you. Please like, share and subscribe our channel.